And if you don't have your calculator, you may want to grab it. We're actually going to use the calculator for these couple of problems. All right, so in section 3.4, we're going to look at problems number 1 and 4. You may see these problems or problems similar to these on the test. All right, and basically in these two problems, we're going to pretty much pick up from where we left off. I believe we were talking about maximums and minimums. And if you graph a parabola and that graph is a U-shaped, for example, I'm just going to put in x squared in the calculator. That would be the graph of a minimum, right? Because it's U-shaped. Keep in mind that the minimum value is actually the y-coordinate of the vertex. Okay, and once again, the vertex is where it bends. If you have an upside down graph, so I'm simply going to put in negative x squared. This would be the graph of a maximum. All right, so that upside down U shape or the hill shape forms a maximum graph. And once again, the maximum value would simply be the y-coordinate of the vertex. All right, so in this problem, we're asked to find the minimum y value on the graph of 2x squared minus 16x plus 64. So basically what we're going to do is we're going to graph this function. We're going to find the vertex, and we're simply going to pull out the y value of the vertex. All right, so I'm going to go into y equals, and I'm going to put in our function 2x squared minus 16x plus 34, right? And I'm going to hit zoom 6. So remember that zoom 6, it gives your calculator the settings of -10 to +10 in increments of 1, both for the x and the y axis. Another thing about finding the vertex using the calculator, you must see where the graph bends, right? So here we can clearly see where the graph bends. So in order to calculate the vertex, right, so keep in mind this is a U-shaped graph, so it's actually the graph of a minimum as described in the problem. I'm going to go into calculate, so I'm going to hit second and trace. Since this is the graph of a minimum, right, we don't actually have a vertex function. Finding a vertex is going to depend upon if your graph is a minimum or a maximum. So here we have a minimum. I'm going to press enter. And then there's 3 things we must do. We must set a left bound, we must set a right bound, and then we have to guess. For our left bound, we must physically set our point to the left of the vertex. So notice this is my vertex. My cursor is somewhere to the left. I'm going to hit enter. All right, and notice that the sideways triangle pops up that falls to the left of your vertex. Now it asks for a right bound. So I'm simply going to move my cursor somewhere to the right of the vertex, and I'm going to press enter. So notice that another sideways triangle pops up that falls to the right of your vertex. For guess, we're simply going to hit enter. And the y value, which is 2, would be the minimum of our function. Right, so we simply found the vertex and we use the y value of the vertex as our minimum value.
What did you do after you set the point for the right?
Yeah, I'll go through it again.
Okay.
I'm going to go back into second and calculate. I'm going to find minimum. All right? It asks for a left bound, so you want to make sure that you're physically to the left. Now your X and Y points don't have to be the exact same as mine, just as long as you're physically to the left. And once you hit enter, right, you should see a sideways triangle that pops up to the right. Now it asks for a right bound, so I'm going to move my cursor somewhere to the right of the vertex. And then you must set this right bound in by pressing enter. Right, so notice you should have those two triangles, and those two triangles should have your vertex in the middle. For guess, I'm not moving to the left, and I'm not moving to the right. I'm simply staying where I am, and I'm going to press enter. Okay, and then we have our vertex 4, 2, but we simply want the minimum value, which would be that y coordinate. Okay. All right, any other questions about this problem? You'll definitely see one like this again. All right, we're also going to take a look at problem number 4. Okay, and problem number 4 kind of deals with that same concept, but it puts this in there like an application form where the minimum and the maximum actually mean something versus just, finding the value. So here we're given that a baseball is hit so that its height in feet after t seconds is given by this function s of t, right, where s would be the height and t would be the time. That's equal to -4t squared plus 28t plus 6. It means that if we input a t value, so remember that t stands for time, so if we input a time, it'll give us the height of the ball at that time. We're asked to find out how high is the ball after 1 second, and then we're asked to find the maximum height of the baseball. All right. So for the very first problem, or very first part of the problem, I'm simply going to insert 1 as t, simplify, and then that should give me the height of the ball after 1 second. Now, I'll actually show you how to do this on the calculator. We can do this manually by substituting t for 1 and simplifying. But here's a way you can do it on the calculator. I can actually take the value 1 and I can store it for t or x or any value. So if I look at my calculator, if I look at the green characters, t is actually above the 4. So if I hit alpha and 4, I can actually assign t a value. So I'm going to take the value 1, and we're going to store that by using this STO key for t. So I'm going to hit alpha and 4, and I'm going to hit enter. All right, so wherever we put in a t is going to substitute t for 1. Now I'm basically going to enter in this function, -4t squared plus 28t plus 6, and once we hit enter, it should substitute t for 1. So I'm going to put in -4t squared, so I'm going to use the negative and not the minus, so that's -4t squared plus 28t plus 6. Right, so now if I hit enter, it gives me 30, which means that after 1 second, the ball is 30 feet in the air.
Can you say how you made the 1 to a t again?
Okay, I hit the STO. So I put in, first of all, you put in the value, right? In this case, we want 1. And then if you hit STO, right, you get the arrowhead, and then you can put in your variable. In this case, I chose t. right? And once you hit enter, it substitute t for 1. So then if you were to enter your function, -4t squared plus 28t plus 6, right? It'll do all the substitution and perform the operations for you. All right. Now, normally when you see me do this, I'm basically going to use the x, the default variables. So like, for example, for this problem, I could just store 1 for x. I mean, because it's easier to substitute for x because you don't have to go through extra keystrokes. And then when I put in my function, instead of putting in a t, I can put in an x. Now, this won't mess up your graph or anything. There's always some value that's stored for x, right? So if you were to go into y equals and graph something, by you assigning a value to x, that will not hurt any graph, okay, or anything else you do. All right, so that's the first half, just finding out the height of the ball after 1 second. Now we want to find the maximum height of the ball. So here again, we have that keyword maximum. So what we're going to do is we're going to graph this function. We're going to determine the vertex. We're going to pick out the y-coordinate of the vertex, and that should be the maximum height of the baseball. So I'm going to go into y equals. I'm going to clear out any functions that I have. And in this case, I'm going to use the default variable x instead of t. So I'm actually going to enter this in as negative. So remember, you want to hit the negative. 4x squared plus 28x plus 6. And I'm going to use zoom 6 to initially graph the function. All right, so from what we talked about, in order for the graph to calculate the vertex, you must physically see the vertex. So after I hit zoom in 6, if the graph doesn't appear on the screen, I'll then choose zoom in 0, right, which is zoom fit. And what zoom fit will do is it will fit the graph to your screen. All right, so now we can physically see where the graph bends and we can calculate the vertex. All right, so as we can see, this would be the graph of a maximum. So in order to find the maximum or the vertex, I'm going to go into calculate. So that's second and trace, which is calculate. We want to calculate a maximum. So here again, we set a left bound. So I'm already to the left. I'm simply going to hit enter. We must set a right bound. So I'm going to move my cursor somewhere to the right of the vertex. Right, so my vertex is here, my right bound is here, so I'm going to hit enter. For guess, I'm going to hit enter. And we have a y value of 55. So after about 3.5 seconds, right, 3.49 is about 3.5. So after 3.5 seconds, the height of the ball is 55 feet from the ground. All right, so any questions about number 1 and number 4? Okay, those are basically calculator type questions. All right, so now I want to backtrack and we're going to take a look at section 3.3. And I'm actually going to pull up the lecture notes. from section 3.3. And in this section, we're going to take a look at methods to solve quadratic equations. All right, and we're also going to take a look at quadratic inequalities. All right, so first we have just the basic setup for a quadratic equation. It's in standard form, which is ax squared plus bx plus c equal to 0. The first method to solve a quadratic equation is by using factoring, the zero product property. Okay, there is it. So what the zero product property says that if we have a product, so A times B is a product, and if that's set equal to 0, then we can set every factor equal to 0. So I believe we've all seen this in action. Here we're asked to solve x squared plus 2x minus 8 equal to 0. So whenever you're asked to solve any quadratic equation, your first strategy should be to factor and solve using the zero factor property. So in this case, we are actually able to factor x squared plus 2x minus 8. That's factored as x plus 4 times x minus 2. Right, so here we have our product, our A, which would be this x plus 4 quantity. And we have B, which would be the x minus 2 quantity. We use the zero factor property to set both of those factors equal to 0. And then we solve. Right, so the solution set is -4, 2. All right. I'm now going to take a look at solving this on the calculator. All right, so we're going to solve x squared plus 2x minus 6 equal to 0 on the calculator, and we're going to use something called the zero, right, finding the 0. Okay, so how do we solve this on the calculator? Well, first off, I'm going to go back to y equals, right, so this requires the use of you graphing. I'm going to clear out any functions in y sub 1, and I'm going to put in x squared plus 2x minus 8. In order for you to use this method, your quadratic equation must be set equal to 0. Right? So if your quadratic is not equal to 0, you have to force it to equal 0, right? And then we can use this zero method. Okay. So first we want to make sure it's in standard form. Next we're going to graph. So I'm going to use Zoom 6 to graph. Okay. All right, and we have the graph of minimum. Now, using the zero method, it's not really important if your graph is a maximum or a minimum. What is important is that these solutions, this -4 and this +2, these are where your graph actually hits the x-axis. Because these solutions are actually x-intercepts. As we're going to see in the following sections, a 0, and I'm going to go back to the document camera. For just a second, because here's some terms you may hear me say. A 0 is also an x-intercept, right? So a physical representation of a 0 is an x-intercept. And an x-intercept is where your graph touches the x-axis. A 0, which is x-intercept, that's also the same thing as a root. So you may hear me say this, the root of the function, a root is nothing more than an x-intercept, and that's nothing more than a 0. These things are also solutions. Right, so all of these terms are one and the same word. All right, 0, x-intercept, root, and solution. Come on back to our shared screen. Okay. Now here's just one thing. When we hit zoom and 0, we kind of put our calculator as having the standard, what are called standard dimensions. And I can physically count where the x-intercepts are, right? This point, if I'm at the x-axis, this is -1, -2, -3, -4. So I know -4 is a 0. This x-intercept, or 0, is at +2. Sometimes you're able to count your zeros or your x-intercepts. Other times it won't be so easy to count them. We can actually force the calculator to give us these zeros. Now the process I'm going to show you, you can only find one 0 at a time. So the first 0 we're going to find is this leftmost 0. I'm going to go back into calculate. So I'm going to hit second and trace, which is calculate. And I'm going to use this 0 function. So I'm going to go to number 2 and I'm going to hit enter. Now, just like in the minimum and maximum function, when you're using a 0 function, you have to set the left bound, set a right bound, and you got to guess. So here what I want to do is I want to set a left bound. So I have to set a left bound to this leftmost 0. So I'm going to move my cursor to the left of the 0. I'm going to hit enter. Right, so you notice that triangle pop up to the left. We're asked for a right bound. So I'm going to move my cursor to the right. I'm going to press enter. For guess, I'm going to press enter. And in this case, we're looking for the x coordinate. So we get -4. All right, so that first 0 or that first x-intercept is -4. We can also find the second 0 or the second intercept point. So here again, I'm going to go back into calculate, which is second and trace. I'm going to calculate the 0. So this time I'm going to set a left bound for my second intercept. Right, so I'm to the left of my second intercept. I'm going to hit enter. I'm going to set a right bound. So I'm going to physically move to the right of the x-intercept. I'm going to hit enter. Okay, for guess, I'm going to hit enter, and we have the x-intercept at 2. Right, so I was able to put out -4 and 2 using the 0 method in the calculator. Now, when we talk about an inequality, we're going to touch back on these x-intercepts or zeros. Right, so any questions about this first example? Okay, you can either factor it, use a zero factor property, or we could either use the zero method on the calculator. All right, now let's look at a couple of other ways to solve a quadratic equation. Okay, and these are more analytical. Okay, you got to actually work these things out. Okay, this is using the square root property, and it says that if you have x squared equal to k, now this property is really specific in that your squared term must be isolated, which means that the squared term and only the squared term must be on one side of the equation by itself. So here we have x squared is equal to k. So x is going to equal to plus or minus square root of k. All right, I'm going to go back to the document camera, and we're actually going to work out a couple of problems. My camera fell down. Okay. So this is the square root property. It basically says if x squared is equal to k, then x is equal to plus or minus square root of k. Okay, there was a lot of other things going on the slides, but this is the main root of what we're doing. So here's an example. All right, we want to solve x squared is equal to negative 12. All right, so we're going to use the square root property. So the square root property says we must have the form x squared is equal to k. So we have our squared term isolated. That's equal to negative 12. Then what we can do is we can take the square root of both sides. If I were to take the square root of, if I look at the formula, the square root of x squared would give me x. If I take the square root of k, I have square root of k. But it must sprout plus or minus. So I can rewrite x squared equal to negative 12 as x equal to plus or minus the square root of negative 12. So now all we need to do is simplify the square root of negative 12. Well, from what we talked about the last time, we must, before we perform any operations, we must rewrite this negative square root. So I'm going to separate this out as, okay, and I must keep my plus or minus. I'm going to write this as square root of negative 1 times the square root of 4 times the square root of 3. Right? Because negative 1 times 4 times 3 is negative 12. The reason why I'm writing it out this way is because we can use the fact that the square root of negative 1 is I. The square root of 4 is perfectly 2. And since the square root of 3 is not perfect, we're going to leave that in a radical. So our simplified answer would be 2i times the square root of 3. All right, there are a couple of problems that are on the slides, and I'm actually going to work those out here. And there are similar type problems. We're asked to solve x squared is equal to -4, and then we're asked to solve x squared is equal to 4. All right, and we're going to use the square root property for both of these. Right, so x squared equal to -4. I'm going to take the square root of both sides. So the square root and the square cancel. On the right hand side, I must insert the plus or negative. Right, square root of 4. So once we simplify square root of -4, we have plus or minus 2i. And for the last example, x squared equal to 4. So here again, I'm going to use the square root property. I'm going to take the square root of both sides. And we have x equal to plus or minus 2. All right, so taking a look at these answers. First, I'm going to start with this plus or minus 2. I have x squared is equal to 4. And I have the solution as plus or minus 2. Keep in mind that from earlier, we said that the solutions are the x-intercepts. So that means that if I were to graph this function, it would hit the x-axis at +2 and -2. So I'm going to do that with my handheld. Hopefully everybody can see this. Well, I tell you what, I'm going to go back to the shared screen. Right, so this is basically what I have on the paper, right? We solved x squared equal to -4. We got plus or minus 2i. We solved x squared equal to 4. We got plus or minus 2. So I'm going to graph this first. These are what are called real solutions, right? Because they really touch the x-axis. So I'm going to turn this calculator back on. I'm going to go to y equals. So remember, in order for us to graph this, it must be in standard form, which means it must be set equal to 0. So in order for me to graph this, I must take this 4 and I must move it to the other side. So I'm going to subtract it. So I'm actually going to graph this as x squared minus 4. Oops. X squared minus 4. I'm simply taking my 4 and transposing it, so I'm changing my sign. All right, so I have x squared minus 4. And now if I graph, I'm going to use zoom 6. Notice that I have x-intercepts at -2 and +2. So now what happens as far as this I is concerned? Well, these are called imaginary solutions. So I'm going to graph this function and let's just see what happens. Okay, here again, I'm going to put this in standard form. So I'm going to add 4 to both sides. So I'm going to graph this function as x squared plus 4. I'm going to use zoom 6 to graph, but notice the graph. This graph bends, but it does not touch the x-axis. Whenever you encounter imaginary zeros or imaginary solutions or imaginary x-intercepts, they never touch the x-axis. These are what are called imaginary solutions. The plus or minus 2, these are called real solutions. I want to touch on this now because later on in this chapter, we're going to talk about imaginary solutions. And so I want you to know from the beginning that these imaginary solutions, they do have bends in them, but they don't touch the x-axis. All right, so we've taken a look at 3 examples that use this square root property to solve. All right, the last one we're going to look at is the quadratic formula. And here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. You will use the quadratic formula basically when your equations are not factorable. Right? If you have a quadratic equation and you can't factor it, that doesn't mean that it doesn't have solutions. That just means that there's another method to find the solution. All right, so let's take a look at using the quadratic formula to solve a quadratic equation. All right, so here we're going to solve x squared minus x is equal to negative 2. Okay. So like I said, the first thing you want to do is you want to see if you can factor it. So my first process here would be to put this thing in standard form. We want to make it equal 0. So I'm going to take this negative 2 and I'm going to transpose it or add it to both sides. So my equation in standard form becomes x squared minus x plus 2 is equal to 0. All right. So now we can see that it's not factorable. Right? It's impossible for me to take 2 negative numbers, multiply them to get a 2, but then when I add or subtract, I get a negative 1. All right, so this is not factorable. That doesn't mean we can't solve it. It just means we have to look at another method to solve. So here I'm going to use a quadratic formula. Now, one thing of the quadratic formula is that it can be used to solve any quadratic equation. You can use it to solve the equations that are even factorable. Right? So how do you use a quadratic equation? The first thing we must do is make sure that our equation is in standard form. Next thing we'll have to do is pull out a, b, and c, because in that quadratic formula, we must substitute in an a, b, and a c. A would be the coefficient of your squared term. So the coefficient of this squared term is understood 1. So a is going to equal to 1. B is going to equal to the coefficient of your middle term. So b is equal to negative 1. All right, we have to make sure we take the sign as well as the number. And then c is going to equal to positive 2. So here's a quadratic formula. All right, x is equal to negative b plus or minus b squared minus 4ac all over 2a. So we're going to use this and we're going to substitute a for 1, b for negative 1, and c for 2. All right, so in the numerator we have negative b. So I must include this negative from my formula. B is a negative 1, so I want to make sure I substitute in b as a negative 1. plus or minus b squared. So again, b is -1. We're going to square that. Minus 4 times a, which is 1, times c, which is 2. And that's all over 2a, or 2 times 1. All right. The next thing we want to do is we're going to simplify. Negative times a negative is a positive. So I'm going to rewrite that as 1. Plus or minus. Within my square root, -1 squared. Well, a negative times a negative is a positive. So -1 squared simplifies down to give me 1. The next thing I'm going to do is I'm going to multiply. -4 times 1 is -4. -4 times 2 is -8. All over 2 times 1, which is 2. All right, so notice within my square root, I simplified my exponent, and then I multiplied -4 times 1 times 2, and I have a 1 minus 8 underneath my radical. All right, so now if I simplify that, 1 minus 8 is 7. So I have 1 plus or minus the square root of -7 over 2. I think the only thing I can do from this point is rewrite the square root of -7 as 1 plus or minus I times the square root of 7 over 2. And then I can pull out my two solutions. So my first solution is 1 plus I times the square root of 7 over 2. My second solution is 1 minus I times the square root of 7 over 2. All right, so you're going to see an example or a problem similar to that on test day. All right, any questions about the quadratic formula? All right, now we do have quadratic inequalities in the class, but you won't see these quadratic inequalities on the test. They're mainly only in the homework problem. You may see 1 or 2 in the quiz, or you may see 1 in the quiz, but you will definitely not see these on the test. But I want to clarify these because there are some homework problems that are based on these inequalities. All right, I'm going to go back to our shared screen. All right, so once again, there's the quadratic formula. And what I would like to just show on these slides, there's a lot of stuff going on these slides. But what I want you to see is that for the equals, right, and this thing is supposed to be on the x and the y axis, but they're only showing the x axis. If you're solving a quadratic equation, right, the equal sign, those things produce a solution set, which were the x-intercepts. Where you see the less than 0, okay, and this is what I want you to visualize from this. Anything that's less than 0 is negative. Anything that's greater than 0 is positive. If you look at P of X is less than 0, notice that it's green, and the green part of the curve is below the x-axis. So on both of these things, P of X is less than 0. Notice that this is a green section and it's below the x-axis. So for anything less than 0, you're looking below the x-axis. For my third or my blue graphs, it says P of X is greater than 0. Notice that the blue parts of the graph are above the x-axis. So what I want you to pull away from this slide is that if you're looking for things that are greater than 0, you want to look for the parts of the graph that are above the x-axis. If you're looking for parts of your function that are less than 0, you're looking for parts of the graph that are below the x-axis. To further clarify this, I want to we'll look at the steps, and then once we look at the steps, we'll actually take a look at a problem. Here are the steps to solve a quadratic inequality. The first step says to solve this corresponding quadratic equation. So we will replace the inequality with an equal sign. Once we solve the quadratic equation, that will give us the zeros, right? The zeros are the x-intercepts. Then we'll use the interval to determine the parts of the graph that are above the x-axis and the parts of the graph that are below the x-axis. Now, since we're using the calculator mostly on this, we won't actually use this third step, which calls for a test value. All right, I actually want to go back into the homework, and I believe this is problem number 10 from section 3.3. I'm sorry, that's problem number 9. All right, we're going to take a look at problem number 9. Notice that this problem contains an inequality. We have x squared minus 7x plus 10 is greater than 0. All right, so how do we solve this inequality? We're asked to type the answers in interval notation. Use integers or fractions for any numbers in your expression. Type in exact answers, radicals if needed. The first thing I'm going to do is treat this greater than as an equal sign. And I'm going to graph in my calculator. I'm going to clear out that function, x squared minus 7x plus 10. All right, so remember from those steps, it says solve the equation. So I'm replacing this greater than with the equal sign. And I want to hit zoom 6 to graph. All right, so I'll replace the greater than with an equal sign, and I graphed. All right. The first thing I want to do is I want to determine the zeros. All right, so remember the zeros are the x-intercepts. Right, so since I have this in a standard format, I can count these zeros. It looks like the first 0 is 2 and the second 0 is 5. Right, so just to verify that, I'm going to use the 0 method in the calculator. So I'm going to hit second and trace. Right, I want to find the 0. Right, so if I hit a left bound, set a right bound, and if I guess, I'm just kind of verifying that my first 0 is 2. My second 0, right, I'm in the 0 function. I set a left bound, I set a right bound. I hit enter for guess, and I have 5. Right, so the zeros are important, and here's why they're important. From the slides, anything that's greater than 0 is above the x-axis. So we're looking for parts of this graph that are above the x-axis. So it appears that this graph is above the x-axis from negative infinity to positive 2. I'm going to put that in negative infinity to positive 2. And it doesn't tell me to use a comma. It asks for interval notation, so I'm going to put in this union. Right? And then it looks like it's also above the x-axis from 5 to positive infinity. So that's 5 to positive infinity. All right, and those are the parts of the graph that are above the x-axis. So when you're asked to solve an inequality, the first thing you want to do is solve the equation, find your x-intercepts, and then this particular problem asks us to find the parts of the graph above 0 or above the x-axis. So I simply located those intervals. In this case, we had negative infinity to 2, right? Because on negative infinity to 2, that part or interval of the graph is above the x-axis. Then it seems like from 2 to 5, it drops below the x-axis, which is negative, and that's not quite what we want. But then from 5 to infinity, it rises above the x-axis. So we have our final solution. All right, any questions about number 9? All right, so at this time, I'm going to stop the recording.